Okay, so today should be a pretty easy day. So we're going to talk about segment addition. So, and we kind of did this yesterday. Yesterday we were just trying to see what the, I don't know, what the value of a segment was. Okay, so for a quick reminder, a segment is just a chunk of a line, and it has a numerical value. By that I mean maybe your segment's 10, maybe it's 2, okay? And it's a chunk of a line because a line goes on forever and ever and ever and ever, okay? And a segment does not. Okay, so we looked at the segment addition postulate yesterday, and it seems a lot more fancier than what it is. So if it says if there's 3 points, point A, B, and C, okay, so point A, B, and C, and they're all collinear, which just means they lie on the same line. B is between A and C, which you can see anyways, okay? So we got A, then B, then C. Point B lies in between A and C, okay? So it says, if you take AB plus AC, or BC, that equals all of AC, which we know that to be true. If you take this chunk plus this chunk, it's going to equal the big, huge chunk, which it should, okay? And you kind of need to know that, I guess, when we're looking at these today. Okay, so the first one, it says, if JL equals 120, what is X, what is JK, and what is KL? Okay, now let's just look at this. So this is saying if JL, let me pull my marker up here. So it says if JL, here's J and here's L, equals 120, okay, and it wants to know what is X, what is JK, so JK is this one, and KL is this one. They want to know what are those. Well, we know what they both are, okay, the whole line segment, and so this is where we're going to use the segment addition postulate, okay? So you can say, for example, that this one is A, this one is B, and this one is C. We know that if you take JK, or in this case AB, okay, and then you take KL or BC, it should equal the total AC or JL in this case, okay? So we know that the total is 120. So using our segment addition postulate, we can take this one plus this one, and it should equal the whole thing. So that's exactly what we're going to do, okay? And most of this is just going to be simple algebra, but you kind of need to know the segment addition postulate in order to do that. So we got 4x plus 6, okay, that's the value of JK. And then we can add that because we're going to add this chunk plus this chunk to give us the 120. So plus 7x plus 15 equals, and we know what the whole segment equals, it equals 120. Okay? Hopefully you guys can see my screen okay. Okay, so on the left side of the equation, we need to combine the like terms. So we can combine the x's, so 7x plus 4x to give us 11x. Okay, and we can combine the 6 and the 15, and that would give us plus 21 equals 120. Okay, and now we need to solve for x. So we're going to say minus 21, minus 21. So I got 11x. I should have shrunk this. I'm not going to have enough room. At least you guys are writing on a piece of paper. Okay. Equals 99. Okay, and we're solving for x. So I got 11x equals 99, so you're going to say divided by 11, divided by 11. Now I'm left with x equals 9. So we know our x equals 9. So somewhere up here, I'm just going to say 9 above this one. That way we know that x equals 9. Now they want to know what is JK. Well, we know JK equals 4x plus 6. Okay? And so now we know what our x is, so you're just going to plug in the x where it goes for JK. And I'm going to change my color here. So our JK is 4x plus 6. Okay, and instead of x, we know that the x is 9 plus 6. Okay, so you got 4 times 9 plus 6. So 4 times 9 is 36. Plus 6 is 42. Oh, I run out of room. Okay, so JK is 42. And I'm going to write that above the JK. And we're going to do the same thing with KL. Well, KL equals 7x plus 15. So we need to plug in our x. Our x value is 9. So you got 7 times 9 plus 15. Is 63 plus 15 is 78. Okay, so KL is 78. Okay, and for those of you guys that write super slow, breathe. Take a picture. That way you have it, and you can copy the rest of the work down, hopefully. And I'm not moving it yet, but that way you have it, or you can watch the video later. Okay? And don't worry, I'm going to do some more. Somewhere on your paper, label that this is number 1. Okay? That way when we move to number 2, when you submit your paper to me later, tomorrow or Friday, I know. Okay, let's look at the next one. Okay, so we got E, F, and G. We got a segment E, F, G. Dang it. Okay, it says EG is 59. Okay, so EG equals 59. What is X? What is EF? What is FG? Okay, the process is going to be the same. So, with our segment addition postulate, if you take this one plus this one, it should equal the whole one. Okay? So, the whole one equals 59. And we know that because that is given. Okay? So, this whole one is 59. So, we're just going to write them out, and I'm going to zoom way in. So, it says 8x minus 14. Okay, that's our first segment, so we'll just pretend, but AB plus, and then we're going to do BC, which is 4x plus 1. All equals the whole segment, which is 59. Okay, and so now we can combine our like terms, and we're going to solve for x. So, think about what can you combine, okay? Well, we can combine the x's, so I got 8x plus a 4x to give me a 12x. Okay, and then I got a negative 14 plus 1. So it's going to give me negative 13 equals 59. Okay, and now I'm solving for x. So I'm going to say plus 13 on both sides. So the 13s cancel. I got 72 equals 12x. Okay, now we still need to get x by itself. So right now it's multiplied. So in order for us to get rid of it, we need to do the opposite. So you're going to divide by 12, divide by 12. So x equals 6. Okay, so above here, above the x, I'm just going to write 6. You guys can just circle it on your page. That's totally fine. Okay, so we know what our x value is now.